All right, there's still a few more people coming in, but that's fine. I can just talk over them while they do that. No problem. All right, so hello, everybody. Hello. Welcome to this talk. Thank you for coming. Yes. I know you just had your lunch, so I'm sure that will have filled you up with loads of energy to ingest as many fast demos as you possibly can. That's how it works, I understand. So nice to meet you all. My name's Steve, and I am a developer, architect type guy at Microsoft, and I work on the .NET team, particularly focusing on web-related stuff, and that's what we're going to talk about today. Now, I imagine that this is largely a room full of web developers. So let's find out. Give me a hands up if you do something related to the web in your job. Yeah, it's like basically everyone. All right. So that's not really surprising because the web is obviously a very dominant part of the software ecosystem. There's a lot of hype around other areas of the software ecosystem at the moment, but the web is still where a very large proportion of overall activity is taking place. And because there's so many people working in this area, people just keep inventing new stuff all the time. Like they're constantly incentivized to come up with the next new thing. And in some ways that's a bit annoying because we keep having to learn new stuff. But in other ways it's great because we get better and better ways to do stuff. And obviously it keeps us in a job as we keep moving from one framework to the next. So that's really going to be the subject matter of this talk. What's going on with the web industry at the moment? Where's it likely to head over the next few years? So to set your expectations, there's kind of two main parts to this talk. We are going to start by talking about web applications. And what I mean by that is something that has some kind of user interface that shows up in a browser. And then after that, we're going to change our focus to stuff that's happening on the back end in the server. And we'll look at ways that web technology like WebAssembly is changing the way that server programming is happening. And I know that some of you will have already heard of things like WASI. If you haven't, that's fine, we'll introduce that. But what you might not know is that WASI is changing at the moment, or it has just changed. In the last couple of weeks, WASI Preview 2 has been standardized, and that changes quite significantly what it is, what it can do. And so we're going to look at what new possibilities now emerge for us. Okay, so let's get started by talking a bit about web applications. And to understand really where we are in the whole sort of timeline of the web ecosystem, let's look at a timeline, specifically right back to where things started. So the web was invented right at the start of the early 90s, and if you wanted to create some kind of web UI at that time, there was only one way to do it. You had to write server-rendered HTML. So you would use a technology like CGI, which is a way of connecting your web server to an arbitrary executable to produce some content. And then you would use something like Perl or PHP to actually script your server to emit some HTML. And then later on, people moved to things like web forms, Django, Rails, and other stuff like that. And that was all we could do back then. It was all we knew. But eventually, people started to outgrow this, because there was this movement around 2005 for a few years, which was called Web 2.0 at that time. And this was a time when people were really strongly incentivized to produce better and better user interfaces in order to try and drive more engagement with their web applications. And so at this point, people really started to write some JavaScript. And at that time, it was a horrible language. Of course, it's not now. It's great now, but it was an abomination back then. And so in order to try and cope with this, people had to use libraries like jQuery that made the thing manageable. And that was great for about 5 years, until people started to outgrow it, because they started to write so much code that their application just became an unmaintainable mess. And that's when the first client rendering frameworks came in. They tried to bring some kind of structure to client-side code, structures like MVC, MVVM, running in the browser. And we had names like Backbone, Knockout, Angular, this first wave of client rendering technologies. Again, it was great for a little while, until people outgrew it. By about 2015, people's client-side applications were too big, even for these early client-side architectures. And that brought us into the era of modern client-side rendering. And I think the biggest game-changing thing there was React. When that was introduced in about 2015, that showed people a whole different component-oriented way of building their client-side applications with a new kind of syntax. And it was very popular, and a lot of other frameworks came along to try and follow on from that and refine that technique. And again, that's been great, but we're starting to outgrow it again. And this time, it's because we've got so much code running in the browser now that it's starting to become a performance issue. It's starting to become a usability issue for people with low-end devices as well. And so there's an emerging collection of web frameworks which are now starting to move things to the server as well. So we went from server to the client, and we're now trying to do server and client at the same time. And that's going to be one of the main focuses for the first half an hour or so of this talk. We'll look at several different frameworks. We'll see how they're similar to each other, and we'll see some of the differences between them as well. Okay, so I'm going to do a series of demos, but the first thing to really understand about this is just this one very simple idea, which is that most of these new frameworks are favoring rendering on the server first and only enabling interactivity for small pieces that are lit up to run on the client. So the easiest way to see that is just to look at a demo. So I'm going to show you a demo of that now. And we're going to start with one of the most popular frameworks in this area, which is called Next.js, a way of running JavaScript components on the server and combining it with running on the client as well. Okay, so I've got this Next dashboard application here. In fact, I'm just going to start it in a browser so we can see what's in there. Okay, and we're going to see how it's server rendered, but we can enable parts of it to run on the client and how we can control that as well. So when that comes up, okay, here we go. We've got our dev team management hub, because what we're building here is some sort of management portal for a software team where the engineering managers need to keep track of all the stuff that's going on. We'll add more stuff later, but right now, just look at this little message that says to do. Okay, well, where's that in the code? That is here inside where is it? Inside app page.tsx. All right. So this is, like I said, a React component. Next is a framework for running React server and client side. All right. But this is not sending any code for this component down into the browser. It's just server rendered. So if we look at the HTML that's coming back in the browser here, a bit hard to read, obviously, but if we search, then we can just about make out that here's where that message is showing up in the HTTP response, and there's no script related to that component going to the browser. The only scripts that we do have are stuff to do with hot reload and things like that. You can ignore that because it wouldn't be there in production. Okay, so since this allows us to use arbitrary React components, let's have a go at putting one in. And I've got this one over here called clock.tsx, which is going to display the current time. All right, we'll look at that more in a second, but let's just add clock in here. All right, save that. Back over here. We now see the current time extremely precisely. Great, very useful. And like I said, that is not sending any code for this component into the browser. It's up to the developer to choose whether to do that. Now, here's the source code for that component. You can see that it knows whether or not it's running on the client. If it's not, well, then it's just going to render statically. It's just going to render this HTML and then it's finished. But if I want to, I can have it run on the client as well, and then it can use logic like this, where it's going to use setInterval to update the time in real time. All right, so if I want to change this over to run on the client, I'm going to add this magic marker, use client, and then back over here, you'll see, that looks horrible. There we go. You can see it now is actually sending the code to the client, which allows that to run interactively there. So that's pretty easy for the developer. Okay, that's pretty good. So why would somebody want to do this? Why would you want to favor running stuff on the server when you could just run everything on the client like we used to in the past? Well, a couple of advantages to do with performance. So, of course, since we're sending less code over the wire, we're not using as much bandwidth. We should be able to load faster. We should reduce our network egress costs from cloud hosting or whatever you're using. So that's clearly some sort of advantage, okay? It also means that it's a lot more likely to work, even if the user's on a very low-end device with a poor network connection, because it's just doing some old-school HTML rendering, and it just has to light up small pieces interactively, according to what you need. It's got another advantage which some people are really into, some people don't quite get it, but it means that as a developer, you are mostly going to structure your application in terms of simple HTML primitives, pages, links, forms, and such like that, rather than things that are specific to a particular client-side technology. So arguably, you might count that as an advantage. And then, of course, the fact that you're doing this doesn't stop you from enabling whatever client-side interactivity you want. We've had this term progressive enhancement for quite a long time. You could argue that's what I've just done when I caused one of my components to run client-side. Okay. Right, so that is just one framework, Next.js, but there's a lot of different frameworks that are emerging that are sharing some of the same ideas. Next, like I said, is running React on the server, Nuxt is running Vue on the server, SvelteKit is running Svelte on the server, Blazor is Blazor on the server as well as on the client, and so on. We're going to look at some of these other ones as we go on. But really what we've got now is a sort of like honeycomb of different frameworks that are all following a similar pattern to each other, even though they have slightly different characteristics among themselves. Okay, and they are kind of all agreeing on what the main features would be that you would need if you want to be productive following this kind of architecture. We just looked at server-side rendering just there. That makes sense, hopefully. But there's a slightly more advanced version of this called streaming server-side rendering. What is that then? Well, this is something that allows you to overcome one of the traditional limitations of server rendering. So traditionally, with server rendering, if you want to show some kind of data in your page, you have to fetch all the data before you can render the HTML, obviously. If you need to do an expensive database query or an expensive API call, your user just has to wait for that to complete before you can render the HTML and return it to the browser. And maybe that takes a little while, and maybe it's not a great experience for the end user. So streaming server-side rendering is a way of overcoming that by rendering the page first without waiting for anything and then patching in different bits of content as it becomes available. So I'll show you that in a couple of different frameworks now, and then we'll see how it actually works behind the scenes by implementing it ourselves from scratch, so you can see it's not actually magic. All right, so the first example of how that can be used is over here on this dashboard page. So I'm going to click that, and I want you to just try and pay attention to how long it takes to load. So I'm clicking now, and we wait, and we're waiting, we're still waiting, and eventually it shows up. All right, so it took about 3 seconds or so. All right, so what have we got on there? Why did it take so long to load? Well, this is showing information from a few different backend sources, some of which take a while. For example, we're displaying our current build status, and we see we've got some failures. It's probably not a problem, because as long as the executive Netflix thing is fine, we'll be all right. We've got a list of incoming issues, which, again, it's probably had to call out to GitHub or something like that. And then finally, my favorite bit, we've got this team activity, which shows us what each of the different employees is doing, like exactly how many lines of code they've written today, how much time they've unprofessionally wasted doing personal web browsing. And then we've got cameras that will show us, what their current mood is and how we should manage them. So anyway, that's a separate thing. That's an emerging field of engineering management called surveillance-driven development, and I think that's probably the future, but I can't see any disadvantages anyway. Right, so the point behind all this is really that it takes a little while to get all this data. And if we have a look in the code for that, let's see why it takes a little while. So here's our page, which has got the build status, team activity, and things like that. And if we look in team activity, you'll see the way it gets its data is by doing this API call to a backend service there. And that takes a few seconds to come back, because it's got to communicate with AI systems and things like that. Right, so how about, what if we just don't wait for that to load? What if we show the page first, even before it's loaded? Now, traditionally, you can't do that with server rendering. You would need some sort of client rendering technology to do that. But streaming server-side rendering allows us to do it. So what we can do is use this component, which is built into React Server components, called suspense. And what that means is, don't wait for this subtree to actually load its content. Instead, just initially render this fallback UI, which in this case I've set to be a spinner, and then when it's loaded, swap it in. So let's see how that looks now. If we move away from here, and then I move back, we still wait a minute for the other stuff to load, but then we see a spinner around that slow loading part of the page. And we're not limited to just a single suspense. We could have a few of them if we want to. So let's put one around build status there, like that, and we'll put another one around incoming issues. Okay, and now if we zoom out a little bit and we reload, we see a few different spinners and all the different parts of the UI kind of pop into place as they become available. All right, so that's pretty nice. Let's now dig a little bit further into how that's working behind the scenes, and let's see how that can be used in other frameworks as well. And we're going to switch over now to Blazor, which I happen to work on, so that's convenient to me. But if you don't know about that, it's just a .NET Web UI framework, which works in a similar way to many of these other ones. All right, so I've got, actually we need a scenario, don't we, for our web application. And I always like having a great business idea to back up my demo. So I've got an amazing idea for this one right now, which I think I'm going to make a lot of money out of, but I really hope that no one copies my idea. Please don't, because it's clearly pretty revolutionary. So how many of you have heard of this? Okay, Twin Peaks, right? It's a cult classic TV show from the 90s. I see not many of you have heard of it. Like, I heard of it. I'm a big fan. You know, I even wear 90s shirts, as you can see, to try and fit into the theme as this. It's an amazing TV show. But if you haven't heard of it, it doesn't matter. All you need to know is that it's a TV show. And in this TV show, people quite often drink coffee. Now, anyone heard of coffee? Yeah? All right. Yeah, now, if you haven't heard of it, don't worry. It's just a drink, all right? And in this TV show, people quite often drink coffee. And loads of people are really obsessive about this. They're really big fans of that. And so I thought, you know, the next big business idea could be a web application that keeps track of when people drink coffee in Twin Peaks. All right, so here's my web app called Twin Peaks Coffee. And I'm going to open this in my browser here. And what you'll see is, let's zoom in a bit. Yeah, there we go. Right, so it keeps track of all the different coffee moments, starting from the very first heartwarming scene where Laura Palmer got killed there in the first episode, right down to the very final episode where Cooper gets attacked while drinking a coffee, and all the other coffee moments that we know and love throughout the years. It's quite emotional, isn't it, when you think about all of them? Okay, and we can search through all these different coffee moments using whatever we want, but it can take a little bit of a while to load because, you know, there's a lot that our database has to query over, and also because I've slowed it down on purpose to make the demo make sense, all right? So look how long it takes to load. If I press that button, we wait, and then it loads. It takes about 1 second. If I do a search, like let's see for all the cases where someone was having a donut and coffee at the same time, and I click, and I wait, and then about 1 second later, it swaps in. And you can see it's basically all the law enforcement people that have donuts and coffee. So, you know, some good cliches. All right, cool. Now, we want to make this a better user experience by using some streaming server-side rendering. Let's see how we can add that into our application. Right, so this is Blazor on .NET 8, and this is purely a server-side, server-rendered application right now. If you've used Blazor in the past, you probably know that it used either WebAssembly or WebSockets to create interactive UI. As of .NET 8, you can still use those, and you will do for many things, but you can also just do straight server rendering with techniques like streaming rendering, as I'm going to show you now. So in this case, when you click on that search button, it's going to perform a query against the coffee database with your search options and get the results, and that's initially going to be a null variable. And in the UI rendering logic, if the results are null, then we'll display this loading message. Otherwise, we'll display the actual results. Okay, makes sense? We never actually saw it say loading, and that's because it's not streaming yet. It's waiting until all the tasks have resolved before it renders the HTML. But we can turn on streaming really easily. And we don't even have to use something like a suspense component, because .NET has a really well-understood system of using tasks for tracking all the different background work. So we can just hook into that, and we know when your application is ready to render. So I'm going to add an attribute called stream rendering onto my page like that. And then when I go back and reload, you'll see that we now see the word loading appears while we're waiting for that to happen. And when I click on this button, loading shows up there. So it starts to feel a little bit more fluid to the user. You don't have to wait as long for things to actually load. All right, that's nice. But again, how does this actually work? Is this some sort of dark magic that we've done? Is this a special browser feature that we're using or something like that, given that it's not any client rendering technology? Well, it's pretty simple browser technology that's been there since the very beginning of browsers, even though people didn't really use it up until this point. So let me show you an example of how we could create our own streaming rendering feature from scratch without using any framework features. I'm going to do that inside this program CS file here right now, and I'm going to add an endpoint onto my server, which is called my streaming, and it's going to work like this. It's going to write a message to the console, hello, not to the console, to the response. Then it's going to wait a little bit, and then it's going to write it again, and then it's going to keep doing that for 5 seconds. Okay, so if that has now worked, I should be able to go in my browser to my streaming, and we'll see hello, 0, 1, 2, 3, and so on. Right, so you can see it's kind of updating the display in the browser dynamically, but it's not really. All it's doing is a very slow HTTP response, and the browser is just showing you everything that it's got up until the current moment. In fact, it's even easier to see that there's no magic if we do it inside curl on the command line, like this. Okay, so you can see, again, nothing magic, it's just a slow HTTP response. And that's fine if all you want to do is just add more and more content incrementally to the page. But that's not what we want to do. We want to update content that's already there based on our loading state. So how can we do that? Well, not too hard, actually. What I'm going to do is I am going to add a little bit of extra code. Firstly, what I'm going to do is set the response content type to HTML, just so that we can use some formatted elements. And I'm going to say, hello, the time is, and then I'm going to say loading, ... So that's our fake loading status. And then back in the browser, you can see it does indeed show that. But I want to populate this part of the UI dynamically while the page is loading. And we can do that by adding a little bit of extra content to the response. So what I'm going to do is add a template element, which won't show up in the UI. It's completely invisible. It's just a template. And that's going to contain the content that we want to put in the UI there. So it's going to contain a bold element with the current time. And then where should that actually go in the UI? Well, to define that, I've added this other element called add streaming block, which is just a made-up name. The browser doesn't know about that. And it says the destination is going to be an element called time, which is this one up here. Now, that won't make any difference initially because the template element is invisible and add streaming block doesn't even exist. So the browser will just do nothing. If I reload, you won't see any difference at all. But you should be able to see in curl that it is, in fact, sending that content to the response stream. All right, so now all I have to do is make my own fake little bit of framework feature that is going to take these add streaming blocks and use it as an instruction to add this template content into the DOM. And that's not specific to my application. It could be shared across all applications. It's pretty simple. It's defining a custom element called add streaming block. And it says, when we see one of those elements, we'll find the content, which is the template element that immediately precedes it. We'll find the destination by looking at that attribute. And then we'll use this extremely naive technique for copying that content into the DOM. A real implementation could be a little bit more sophisticated than that. But anyway, that should be enough for what we want. So if I go back and reload now, then we see it does, in fact, actually work. So the clock is updating as the page is loading. And we can use that technique to paste in arbitrary content to the response as part of our long-running response. And that's exactly how this is working here. So when the response initially goes out, it contains these empty placeholders. And then as more and more data becomes available, the server is sending more chunks of response and causing them to get patched in to different parts of the page. All right? So there's no real magic to it. It's fairly simple. You could implement that yourself. You might want a real implementation to be a bit more sophisticated, like preserving other parts of the DOM that aren't affected, things like that. But you get the idea of it. Okay, so let's move on to the next feature, which is common to all these different frameworks, which is called enhanced navigation or enhanced form posts in some cases. And this, again, is to overcome another one of the limitations of server-side rendering. So traditionally, with server-side rendering, every page is completely independent of every other page. If the user follows a link, the browser will throw away the DOM completely, it'll throw away all the JavaScript state and create a new page from scratch, potentially reload a load of static content and set up the new page. And that can be quite a slow and jarring experience for the end user. So enhanced nav is a way of getting the kind of fluidity that you have with a client-side router, even though you're doing server-side page loading. So let me show you that. And I'm going to show you that from the point of view of a different framework called SvelteKit. SvelteKit, I think, is the one that introduced this terminology of enhanced nav, even though lots of others now use it. So let me start up that one. Let's get out of here and go into Svelte demo. And I don't have a cute scenario for this one. It's pretty much just what you get when you create the project from their template. All right, so when you create a new Svelte project, you get something like this. It's got a nice little counter example, which I always love. It's got an about page. It's got a Wordle clone for some reason. And it's got a to-do list, which is important. All frameworks need to have a to-do list. And this, if we look at it, is just a plain HTML form, because once again, this is just doing server rendering. It's not actually doing client-side stuff right now. So this is the HTML form that you can see there. And because there's nothing special about it, when I submit that form, the browser will throw the whole page away and create another one from scratch and reload all the stuff. And to see that more clearly, let's check out the network tab and see how many files get requested. All right, so when I load the page, you can see the browser's done 64 requests there. It would be smaller if I made an optimized production build, but that's not important. The important thing is just that you remember that number 64 and see how it changes as we do this stuff. All right, so let's clear that out, and I'm going to add a new thing. Let's put, hey, NDC, and then I'm going to press Enter, and we see that the browser submits the form, throws the page away, and does another 63 requests to load the updated page. So it cached one thing, apparently, but everything else had to be reloaded, and all the other state will have been thrown away. But with enhanced nav, or enhanced form posts, we can intercept that form post and resolve it without a full page load, without really having to change very much of the developer's code. So let's add that in now. I'm going to go over to the code for that, which is in here. That would be inside the to-do page. Okay, here we go. Right, so here's our HTML form that we just submitted there. You can see there's nothing, unusual or magic about it. And we can add this special attribute called useEnhance, which is built into SvelteKit. And that is going to tell it that we want it to upgrade this form when scripts are available to resolve it using client-side code without having to, change other aspects of our server-side code. All right, so let's try that now. So I've reloaded. You'll see it's done 64 requests again, if you can see the bottom left corner. And then I'll add another thing, and I'll hit Enter. And you can see now it only had to do 2 requests to resolve that form post this time. A single request to send the data, and then it does another request to get the updated page state from the server. Okay? And that creates a much more fluid user experience for the end user because, they don't have to watch the browser sort of unload and reload a new page. Okay, now we're going to look at how that works behind the scenes as well in a minute, but I want to show you that from the Blazor point of view now, because I want to show you that that's not just about performance. It's also about changing the actual practical user experience as well. So let me show you an example of why it's going to make a difference. So notice that in my form here, I've got this advanced checkbox here. And when I click that, it's going to open up this extra part of the form where we can pick a location. So let's look for, a crime scene. I always love coffee at crime scenes. And there was 2 of those, apparently, or it was the same incident where 2 people were having coffee. Good to know. All right, but did you notice that the advanced checkbox became unchecked when I did that? What's going on? I didn't uncheck it. Let's just try that one more time. I'll click it to open it, and then I'll submit. And notice it just becomes unchecked again by itself. So what's that about? Is that a bug? Well, it's not really a bug. This is just how server rendering works and has always worked. Because we're throwing the page away, then we'll lose all the state of things like whether a checkbox is checked or not. And of course, as the developer, you can do some work to manually preserve that state across page loads if you want. You can store it in local storage. You can try and round trip it through the form post data or whatever you want. But it's quite a pain to have to do that. And with enhanced navigation and enhanced form posts, it's much simpler because you can just retain any part of the page you want when things like forms are posted. So let's do that right now. I'm going to go into the source code for that, which is back here. You saw that before. Okay, and on our actual form element here, I'm going to use Blazor's equivalent to useEnhance, which is data-enhance. All right, and that again is going to tell the framework to resolve that form post using client-side code, which is built into the framework. So now, when I open this checkbox, this location area down here, and then I click the button, notice that it does not lose the state of the checkbox anymore, and everything just works in the way that the user expects. So now we've got the ability to retain parts of the page when we're doing things like form posts, and we can do streaming rendering to update the UI during different loading phases. It really starts to feel like quite a fluid user experience. It feels basically identical to a client-side SPA application, even though we're not relying on any client-side SPA technology. This is Blazor, and it's not using any WebAssembly. It's not using any WebSockets in this case. It's just using these techniques of streaming rendering and enhanced nav. Okay. All right, so let's now dig a little bit deeper into how this is really working behind the scenes. Now, you probably don't really need to know this, but you're an advanced bunch of people, and I'm sure you want to know, what is going on here? How does this actually work behind the scenes? And you'll find out that it's not very difficult, and in fact, again, you could implement this from scratch without needing the framework if you wanted to. And to prove that we're really doing it from scratch, I'm going to take Blazor's standard JavaScript library, Blazor Web.js, and just delete it from my application completely, which I very much don't recommend normally. But we're going to do that just now because we can then see that everything that happens is stuff that we've implemented ourselves. All right, so let's go over here onto this chat page, and I want to show you what happens when we navigate from one place to another. Okay, so because I have just turned off the Blazor standard enhanced navigation thing, when I navigate from one page to another, it's going to have to reload everything from scratch. So if I load, you'll see that it's done 13 requests to load that page just then, and I'll clear that, and then I'm going to navigate to another page, like that, and you will see now it's done 12 requests to resolve that. So again, one thing was cached, but everything else had to be fetched again, and it's thrown away the whole page state and created another one. So let's implement our own enhanced navigation to fix that right now. It's not very difficult. So we will add a little bit of standard script, which is going to look like this, a bit of JavaScript that's going to detect any click events in this document, and we're going to check, was that a click event on a link tag, an A tag? And if it was, we're going to say, hey, don't do your normal thing, don't follow that link, don't update the URL, just do nothing, right? Apart from alert the fact that we know that this has happened. Right, so it's just a starting point for us. So now, when I click on this link to chat up here, you'll see that it does not update the URL. It's still where it was before, and it just displays this alert box instead. All right, so next step, I do want it to actually update the URL, and I want it to fetch the content dynamically using client-side code. So let's add a bit more JavaScript. We are going to push the URL that you just clicked the link for into the history stack, like that. And then we're going to call perform enhanced nav, which I haven't implemented yet. That's going to do the main body of the work. Right, and the initial performed enhanced nav is going to look like this. We're going to fetch the contents that come back from the server at that URL and read that as a string called HTML. And we're going to display it in a minute, but for now, let's just alert it onto the screen to check this is working. All right, come back over here, and I will click this now. And you'll see this time the URL did update. It did update to chat, which is what I just clicked on, but it doesn't display the content in the browser. It's just alerting it onto the screen like that. So finally, all we have to do is simply update the DOM using the content that we've just fetched. And there are many ways you could do that, some of which are much more sophisticated than others. This is an incredibly naive technique. All we're doing is just parsing the HTML and just completely overriding the entire document body with it. But you can imagine a more sophisticated way of doing it through some sort of diffing algorithm that retains the parts of the page that don't need to change. And in fact, that's exactly what Blazor does do behind the scenes. But this will give you the idea of what's going on. So now, if I'm over here on chat and I click onto merchandise, it updates the URL and the content like that. And if we have a look in our network tab, I've done a reload. You'll see it's done 13 requests there. And then I'm going to go and click on the merchandise page. And you'll see it's only done one more request there because we intercepted everything and just implemented it ourselves. Okay, so that really is pretty much all there is to enhanced navigation. A little bit more is needed for a real implementation to do with like integrating with back and forwards and things like that. But you've got the core idea of it right there. Okay, so that's enough about enhanced navigation. Let's move on to our last topic, which is interactive islands. Now, you might think that we've already talked about that because, you know, that's where we started when we looked at that clock thing at the beginning. But I want to show you this a little bit more from the perspective of a couple of other frameworks as well. I'm going to finish off showing you Blazor, and then we're going to move on to look at Astro, which is a little bit different still and has got some interesting characteristics of its own. So to complete the story for Blazor, we've got a page over here called Chat, which it does work as a pure static server rendered page, but it doesn't work very well. And to show you what I mean by that, let's say that we want to participate in this fascinating discussion about do they film with real coffee. And can you see at the bottom, it counts the number of characters left that you can type in. Let's say, yes, it's all lattes, like that. It's not updating the number of characters at all as I type. And I can submit that, yeah, and it does show up on the screen, great, but it doesn't work so well if there's multiple people on the site at once. For example, I'm going to open a second window here, like this. All right, and then I'll say down here, from Starbucks, like that. And then I'm going to send that. And that last message that I've just added in this window does show up here, but it doesn't show up to the other person. Why doesn't it show up to the other person? Because why would it? Like, there's no live connection from this page to the server. How would it even know that another message has come in? If the user manually reloads like that, then they'll get to see the updated message, but that's not really what you want for a chat experience. So Blazor, like many of these other frameworks, has got the ability to mark parts of your page as running interactively. And if you've used Blazor before, you'll know that it can work with either WebAssembly or with server rendering. So I'll show you how we can add that quite straightforwardly right now. Here's my chat thread page, which loops over all the messages and displays them. And I'm going to add a render mode directive here, and I can mark it as being interactive on WebAssembly or server or even auto, which switches between the two, depending on caching state. But I'm going to pick server, okay? And then let's see if that actually works now. So hopefully, oh, no, wait, hold on. I need to restart because of removing that script earlier. Let's see if this works now. Yeah, so now can you see that the number of characters remaining is updating as I type? That's good. And what's more, if we've got multiple people on the site at once, let's reload, then if it's difficult to see, isn't it? But if I send that there, then you'll see it's immediately on the other window behind the scenes as well. Because we do now have this live WebSocket connection between the browser and the server, because that's what Blazor Server does. And it's smart enough to start and stop that connection as the user navigates around. So when the user's on this page, the WebSocket connection's there. If they go over onto the search page, then the framework will say, hey, I don't need that WebSocket connection anymore. It'll shut it down, or it would restart it if the user comes back. So you only pay for that server connectivity at the time you're actually using it. Okay, so let's now move on to another framework, Astro. And that's quite interesting because it's unique among all these different frameworks in that it's not tied to any particular client rendering technology. Astro itself started as a simple static site generator, and then over the years they added more and more functionality to integrate with client rendering technologies. Let me show you what we can do with that and how it is a little bit different. Let's get rid of some of this. And here's my Astro team portal, which we're going to add some stuff into. Let's start that up like so. And once again, I didn't really do any cool design on this. This is just the standard project template that you get when you create a new Astro project. The only thing I've added is this link to exciting counters, because I love counter-based demos. And we're going to add some counters to that page there. Right, let's see the code inside there. Inside pages, counters. All right, here's the code for that. You'll recognize that message from earlier. And you might look at that and say, okay, so what is this syntax then? Is that React, maybe? It looks a lot like React. The answer is no, it's not React, it's not Vue, it's not anything else. It's just Astro's own built-in template syntax. And this only does server and static rendering. This is not doing anything on the client. It's just a way of constructing HTML using templates. Okay, but I've also got this folder over here called components. And inside there, I've got a React counter and a Vue counter. Because Astro itself is not tied to any client framework, it allows you to work with whichever ones you want, or even multiple ones. So here I've got a counter implemented in React, which has got a button, which you click it, and it increases a count, and it uses use state and things like that. Okay? And then I've also got a Vue counter, which does the same thing using Vue as well. And because Astro integrates with these things, I can add a React counter to my page here, and you can see the tooling automatically imports that for me. And then back in the browser, we've now got our React counter in the page there. And I could do the same thing with the Vue counter as well, like that if I want to. And now we've got React and Vue at the same time. But that is not sending any code for these to the browser. Just like these other frameworks that I talked about, it's server rendering first, and if I click the button, nothing happens at all. If we want it to send the code for these into the browser, we have to tell it to do that specifically. So I'm going to tell it that I want it to load these component instances in the browser. And if I do that, then once I go over here, now you'll see they do actually work. And just to emphasize that this is a little bit different from what we would do with other frameworks, I'll show you a weird thing we can do. So since in my React component, I've given it the ability to render child content like that, I can pass anything into it to render it inside that React component. So if I wanted to, for some reason, I could take my React component and put a Vue component inside it as a child, and it's there, yeah? So that's nice. Yeah, no. What do you mean? This is the future, I'm sure, combining as many frameworks as you can. And in fact, if you were really crazy, which of course you are, we could put a React component inside that as well. So now we've got React inside Vue, inside React, inside Astro, and everything just works together, okay? Right, thank you. Okay, so that just goes to show that we've got a lot of flexibility with these kinds of things, and it's up to you, the developer, to choose what runs on the server, what runs on the client, what technology is used for what, and you've got a lot of flexibility with all that. So there we go. That is what we're going to look at in terms of web applications today. Hopefully you can see there's a lot of commonality among these things. In many ways, it makes your life more difficult as a developer because there's just so many different ways of doing things now, but it does also give you the power to tune that user experience to be as lightweight as you want while still having whatever level of interactivity you want. Okay, so let's move on a little bit from web UI stuff, and we'll change our focus now to stuff that's happening on the server. And I know that you'll have heard of WebAssembly before. I'll introduce it in a second just in case you haven't. Most of you will have heard of WASI, WebAssembly System Interface, which is a way of running WebAssembly code on a server in order to do server-y things. So why would anyone want to do that? And why am I talking about this now? The reason I'm talking about this now is because stuff is changing in this space right now, and I'm going to show you how it's changing. All right, so to understand the background of this, let's do another timeline. WebAssembly itself has been around for quite a long time now. So it first sort of appeared around 2015, and it actually became available by default in all the browsers in 2017. And that's the thing that, if you've ever used Blazor WebAssembly, is what's allowing .NET to run in the browser there. And the core goal of this at that time was to make it possible to run arbitrary code in a browser. So in 2017, if you wanted to run JavaScript in a browser, obviously you could, because that was what it was designed to do. But if you wanted to use C or Rust or Go or whatever else, then WebAssembly was the way that that was possible. You could compile from another language to WebAssembly, a bytecode that runs inside a browser. That's great. It's fast. It's sandboxed. Lovely. But then a few years later, people started to say, hey, this stuff is really good. Wouldn't it be nice if we could use WebAssembly to do our server-side code as well? Because then we could write our code in any language we want, and it would work on any operating system, on any CPU type. It would still be like nearly native speed, and it would be more secure because of all the sandboxing. And people said, yeah, that would be kind of cool, but what would it even be able to do anyway? Because WebAssembly doesn't have a way of interacting with the outside world. In a browser, all it can do is communicate to JavaScript because it's inside that sandboxed. What can WebAssembly do when it's on the server? Nothing. So that's why WASI came along. WebAssembly System Interface gave WebAssembly on the server a way of doing useful stuff. It was a set of standard APIs for doing server-type stuff, like working with files, network sockets, clocks, environment variables, stuff like that, okay? And the design of this was inspired by POSIX. That's a standard set of operating system APIs that's widely used in Linux. It's also available on Windows and Mac. And this design has been around for a long time. So POSIX is like a 1970s technology, pretty much. And it made sense for WASI to start with that because the goal was to be able to get existing code to run, and it was successful. But it's not the future of WASI. The reason why POSIX is not the future of WASI is, one, it's a sort of many decades old view of computing. It doesn't really represent the modern era of cloud programming. You know, it's just about file handles and not about things like distributed queues and blob stores and AI inference and stuff like that. Secondly, because it's not extensible in any way. All you could use is just the standard APIs that were built in, and there's no way of standardizing your own other APIs on top of it. But it wasn't the long-term vision. The longer-term vision is something that we're just coming to now, and this has just been standardized in the last couple of weeks, WASI Preview 2, and that brings a new programming model that allows us to do some new things, and the core idea in that is something called the component model. So let me introduce that to you now. This is how different pieces of WebAssembly can work together. So the central thing behind this is a new interface definition language called WIT, WebAssembly Interface Types. And here's an example of that. So you can imagine this as part of some kind of e-commerce system, and I've defined an interface called ordering, and inside that, we've got this type called product with a few different fields on it, and I've also defined a function called add to cart, which takes an item and it returns some kind of result, okay? Now, what language is that written in? No language. It's not Rust, it's not C, it's just a language-independent format for defining a set of functions and data types. But you can use that with any language that you want. For example, you could take that WIT file and you could have some Go code and compile them together to produce a WebAssembly component that uses those APIs. You could also take some Rust code and compile it with that WIT file to produce a different WebAssembly component, or you could take some C# code and again use the same WIT file to produce another WebAssembly component. And because all of these share the same API definitions, we know for sure that they can actually work together at runtime. So obviously that gives you cross-language interop, but it's not just about cross-language interop. That's been a solved problem for decades. The main new innovation that this is bringing is that it's still taking advantage of all the benefits of WebAssembly. So even though all these components are working together, they can still be independently sandboxed, and they can only communicate through the channel defined in these WIT files. So when you take a dependency on a WebAssembly component, you don't actually have to trust it, really. You don't have to trust that it won't read your memory space or mutate your data when you didn't expect it to. You don't have to trust that it won't access the file system or the network or whatever else, because you know that all the components are running in their own little sandboxes, and all they can do is communicate across the API interfaces that are defined in the WIT files that you know about. So to understand that a bit more, let's have a go at building something with it, shall we? And we're going to build a little web server now, which uses components written in multiple different languages working together. And the main language we're going to use is C#, because I know that most of you in here will see that as your main language. But just before we get to that, we're going to write a bit of Rust code for our actual web server. Now, don't worry if you don't know Rust, you've never seen it, or you hate it, or whatever. It doesn't matter. It's not going to be very much code. It's just going to be a little web server, and we're going to make it extensible and pluggable so that we can bolt other functionality into it using other languages. Okay? So let's find our starting point for this. I'll close some things down and have a look over here. All right. Okay, so here is our Rust web server. It doesn't have very much code in it. It's just a single function which takes an incoming request, and it's going to read the current URL in that's coming in from the browser or whatever. It's also going to determine the current timestamp, or it will do later. It's just hard-coded right now. And it's going to print a message to the console. And then it's going to determine what the response content should be, and it's going to send that response back to the browser with a 200 status. All right, hopefully that makes sense, even if you don't really know Rust syntax. We're going to compile that now, and rather than compiling to native code, I'm going to compile it to a WASI Preview 2 component. Now, this talk is not really about the build systems, so I'm not really going to talk about how that works. I'm just going to use a little script that I already prepared that builds stuff, converts it into a Preview 2 component, and starts it up inside this little runtime called Spin, which allows WebAssembly components to interact with a network listener. Okay, so when I open this in a browser, now you'll see it says to do, call external component, and that is not very surprising because that's exactly what we hard-coded into our source code. All right, makes sense. But we want to make this into a pluggable web server now, where you can add functionality using any other language as a WebAssembly component. And to do that, we are going to need to define a WIT file to define the API contract that we're allowing people to use. And in fact, I've already written this WIT file. It's over here. You can see webserver.wit. And it's got this interface web app, and it says that to be a plugin for a web app, you need to do two things. You need to be able to give a timestamp. You also need to be able to give the current to give some response for a given request. So a URL comes in, and you need to return a string, which is the HTML that you want to send back to the response. And then this other stuff down here is quite a weird syntax. I don't know why they use the word world. But basically, you can decide when you're consuming this, do you want to work on the web app provider side, which means you're going to export an implementation of this stuff so that people can call you, or do you want to be the server, which means you import this stuff so that you can call into it. So that's what this is doing. It just allows you to specify which side of the contract you want to be on. Okay, so let's have a go at actually using these functions from our Rust code. So I want to call into this get timestamp, which I'll do there, and I want to call into get response HTML, which I'll do there. Now, initially, the Rust tooling will display these red squigglies, and it'll say, like, what on earth are you talking about? I don't know what get timestamp is. That's not defined anywhere. You're obviously doing something wrong. And that's because I haven't wired it up to this WIT file in any way yet. The way we do that in Rust is using this this macro called WIT-bindgen, which allows us to point to a particular WIT file, which I've done in my build config file, and say which side of the contract we want to be on. Okay, so now I've done that. I'd still get squigglies, but it's a little different. This time it says, hey, I do know what that is actually, because there's just been some code generated for that in the background. Do you want to import it? So I'll say, yeah, I do want to import that, and this one as well. And now the squigglies will go away because we are actually referencing this API. Okay, now let's try and rebuild and restart. And it's actually not going to work now. It won't be able to start the server. You see, we'll get a build error, and it will say, hey, you're trying to use this thing called getTimestamp. I went looking for that, and I got nothing. Like, what do you mean? You're trying to reference something, but you haven't provided an implementation for it. So that makes sense, hopefully. We can't call something without having an implementation for it. Let's provide an implementation, and we're going to do that using C#. So I'm going to switch over to Visual Studio now. And I've got a project here. It's kind of an unusual project because it doesn't contain any source code whatsoever. There's no C# files in there because I really want to do this from scratch so you can see everything. And if we look in the CS proj file, you'll see there's not a lot in there. It's just a pretty standard .NET 8 class library project. Okay, so first thing I want to do is compile this as a WebAssembly component. We could do that in a few different ways, but I'm going to use this experimental package called Wasm Component SDK. And what that is going to do is it's not going to use the mono runtime, which we normally use for .NET on WebAssembly. It's going to use native AOT compilation instead to produce a fully AOT'd WebAssembly file. It's just an experiment we're working through at the moment. And then I'm also going to configure the fact that I want the output to be WASI-flavored Wasm. Okay? So once I've done that, if I rebuild, we should see that the build process goes through a few extra steps compared to what you'd normally see. And it's gone through this LLVM phase, and it's eventually produced a file, which is a WebAssembly file. But it's not a traditional WebAssembly file, it's a WASI Preview 2 component, which knows how to be linked up to other WIT files. Okay, so let's actually link it up with a WIT file now. How do we do that? Well, with this tooling, we can add a WIT into one of our item groups, and here you'll see that here's my reference to the webserver.wit file, and I've defined that I'm on the web app provider side of this contract, which means that I'm going to implement stuff. And if I try and build now, we should now get some build errors because it'll say, hey, that contract says that you need to implement this thing, but you haven't done, so I can't build this anymore. So let's implement that. I'm going to add a new C# class, and I'm going to call it web app impl. You can actually call it anything you want, that doesn't matter. And then I'll go into here, and I'm going to drop in a starting point. So because of this build tooling, behind the scenes, it's code generated an interface that matches the thing that we're supposed to implement. The naming's a bit weird that it doesn't start with I, but that's being fixed at the moment. If I go in there, you'll see this is the interface that's been generated, and it looks just like that WIT file. So if I come back here and do a control dot, I can say, right, I need to implement this now, generate the outline for that, and let's put in an implementation. This is going to be quite easy. Let's just have datetime now ticks. I don't need that, that'll do. Okay, and for get response HTML, I'll say, hey, NDC from .NET. Okay, nice. And I'm going to rebuild that now. Okay, so hopefully, because of the fact that my build script wires these two components together, I shouldn't get a build error from this anymore. It should now actually start up the web server, and it does. So open up in my browser, and you can see we've now got our Rust web server, which is able to call into our C# code to provide part of the response. That's good. But I don't just want to return a hard-coded string. I want to make this into a little static file server. You'll see I've got a couple of markdown files right here, such as this one here. And I want it to serve whichever markdown file corresponds to the current request. So I am going to paste in a little bit more implementation here, which is going to take that URL, and it will say, if it ends with a slash, we'll normalize it by adding index onto it, because I want the home page to serve index.md. Then we'll have a look and see if that file exists. If it does, we're going to return it to the response. Otherwise, we'll say not found. Okay? So we'll start our web server again, and we'll see if our updated logic now actually gets used. Let's find out. Come over here and reload. And it does. It's now serving our markdown to the response. Now, of course, it looks absolutely disgusting. That's because I haven't formatted it as HTML yet. It's just returning markdown string into the browser. And I could implement the markdown formatting in C#. There are markdown formatters available for .NET. It's not difficult. But that's not really the point of this talk. I want to show that we can work with yet another technology or another ecosystem. So what I want to do is define the abstract notion of markdown formatting as yet another WIT file, and then I'm going to provide an implementation for that in Go, in this case. Right? Now, you won't be surprised to hear that I've already done that. That's over here. And if we look in there, you'll see here is the markdown formatter WIT file. It defines a single function, format as HTML, which takes the markdown as a string and returns another string, which is the HTML. And once again, you can decide which side of the contract you want to be on. And here's the actual implementation in Go. Don't worry if you don't know Go. There's nothing clever about this. This is just using an open source library called Go Markdown, which will do the formatting. And then it's got all this block of code down here, which is what's needed to actually instantiate that and push the incoming string through the markdown formatter. Okay, now don't worry about reading that. We want to consume that now from our C# code. So to do that, we will go over here and add a reference to yet another WIT file, like that. And we'll say this time we're going to be on the consumer side of it. And one minor weird glitch at the moment, which is a bug that should hopefully be fixed, is that whenever you import something, you have to manually add this weird definition in order for it to actually work. But you can ignore that, because hopefully that would just go away. All right, so I can now compile my C# code, and I've got a reference to this markdown formatter. Even though I haven't called it, there's no build error, because you don't have to call something just because you've implemented it. But it will be there and available for me to call now. And I happen to know that the naming convention it uses for something like this, markdown functions, will look like this in C#, markdown, functions interop, like that. And as long as I've spelled that correctly, then I should be able to import the namespace for that. And then I can call format as HTML, like that. And then hopefully everything will be wired up to call across into Go like that. All right, let's see if this works. We're going to shut down the server one more time and restart it. And then go back into our browser and reload. And indeed, it did actually work. So we've successfully got our Rust web server as a WebAssembly component calling into a .NET plugin, another WebAssembly component, calling into a Go library, another WebAssembly component, and we can serve multiple pages and things like that. Okay, so obviously it's a kind of a very basic and small example there, but it leads to potentially quite an interesting future for this kind of technology. So the overall goal of something like this, like the kind of dream you could imagine for it, would be a sort of cross-language package ecosystem. So right now, we've got package managers called things like Cargo and NPM and NuGet, and they're all tied to specific languages. But you could imagine a future one, which is based on WebAssembly and WIT, where you can consume those components from any language you want without needing to care what it's written in. And if you want to contribute a component, again, you can do that from any language you want without having to align with what your consumers of that are doing. And then at runtime, this stuff can run in any operating system, on any CPU type, at high speed, and with full sandboxing. So will that be the future of server cloud programming? Don't know. But that is what WASI is trying to achieve at the moment and where it's just going right now. Okay, so that is all we've got time for. I hope that's been of some use to you. I hope you've seen something new, at least. I'm around if you want to come and ask me questions or whatever, that's fine. But other than that, I hope you have a really good rest of the conference, and I will see you all around.